Let's do some more examples of finding the derivative using the quotient rule. Here we're asked to find the derivative and simplify f of x equals the product 3x minus 1 times 2x minus 2 raised to the negative 1 power. Because the second factor, 2x minus 2, is raised to the negative 1 power, that presents a little bit of a problem. Because it's not raised to the first power, we have to treat it as a composite function. But we don't know how to differentiate composite functions yet. The good news is that we can rewrite this function as a rational function. F of x can be rewritten as an equivalent function of 3x minus 1 in the numerator over 2x minus 2 in the denominator. Now we can differentiate using the quotient rule. The quotient rule is fig minus gif over g squared, where f represents the numerator and g represents the denominator. We're going to need f prime and g prime to execute this. So let's go ahead and write f prime and g prime in the margin of our work. F is 3x minus 1, and the derivative of f is 3. G is 2x minus 2, and the derivative of g is 2. And now we just fill in the blanks. F prime is 3, and we multiply that times g, which is 2x minus 2. And we subtract from that g prime times f. G prime is 2, and f is 3x minus 1, and that's all over g squared. Now let's simplify the numerator. Distributing and removing parentheses in the numerator gives us 6x minus 6 minus 6x plus 2, and 6x minus 6x subtracts out, and negative 6x plus 2 leaves us with negative 4. So now we have the expression negative 4 over the difference 2x minus 2 squared. This is a fraction, so we need to make sure it's fully simplified. So let's expand the denominator. Squaring 2x minus 2 gives us 4x squared minus 8x plus 4. And now we see that we can factor a 4 from each term in the denominator to give us 4 times x squared minus 2x plus 1. And the 4 in the numerator divides out with the 4 in the denominator to give us our fully simplified derivative, which is negative 1 over x squared minus 2x plus 1. Now you can leave the derivative just like this, or you can choose to factor the denominator again and write it as negative 1 over the difference x minus 1 squared. Either of these is acceptable. In this example, we're asked to do the same thing. Find the derivative and simplify. F of x is equal to, in the numerator, 2 minus x minus the square root of x, and in the denominator, x plus 1. In the quotient rule, f will represent the numerator, and g will represent the denominator. The quotient rule is fig minus gif over g squared. Again, we're going to need the derivative of the numerator and the derivative of the denominator, so let's find those first. The derivative of the numerator is negative 1 minus 1/2 x to the negative 1/2. And the derivative of the denominator is 1. Now we just plug this information into the quotient rule. F prime is negative 1 minus 1/2 x to the negative 1/2 power. We multiply that times g, which is x plus 1. We subtract from that the product of g prime, which is 1, times f, which is 2 minus x to the 1/2. Now you'll notice that I've rewritten square root of x as x to the 1/2. And we'll always do that when we're finding the derivative of a root function. It's easier to find the derivative of a root function writing that root in exponential form. Square root of x is the same thing as x to the 1/2. And all of that is over g squared. Now let's simplify the numerator. Multiplying the two binomials in the first term together gives us negative x minus 1 minus 1/2 x to the 1/2 minus 1/2 x to the negative 1/2. Distributing the negative 1 in the second term gives us minus 2 plus x to the 1/2. And that's all over x plus 1 squared. Now simplify the numerator by combining like terms. Negative x plus x adds out. Negative 1 minus 2 is negative 3. Negative 1/2 x to the 1/2 plus x to the 1/2 is 1/2 x to the 1/2. And then the only remaining term in the numerator is negative 1/2 x to the negative 1/2. And all of that is still over x plus 1 squared. Now what we have here is a complex fraction. So we need to simplify that complex fraction by multiplying by 2 in the numerator and the denominator. Multiplying by 2 in the numerator gives us negative 6 plus x to the 1/2 minus x to the negative 1/2. And multiplying the denominator by 2 gives us 2 times the sum x plus 1 squared. And that's our fully simplified derivative.